So if you may recall, back a couple units ago, this is where we started, okay? We started with this idea that computer science is solving a problem with a computer. You're now beyond that. You know that you're going to do coding in a language that translates what you think into what the machine can do. And then you chose a language. Well, I chose it for you. And then we advance from there that would involve a user interface. Just to remember, it would give the user something to interact with. Oh, now you have the ability to make that a user interface. It would give that the users would give us stuff through the user interface. Oh, you know, there's things like text boxes where they can type stuff in. And we can give them stuff in things like labels and pictures, okay? So this idea of inputs and outputs coming through a user interface, okay? We then also transitioned into that this would be typed in some sort of an editor and compiler that would turn our code into the stuff that the computer could use. That's how the translation would occur. And where that eventually led us to was this unit in variables, which we just finished. And really, this is one of the three fundamental coding aspects that we want to get across in this unit, in this course. So variables is essentially memory. It's the ability for the computer to remember things. It's something the computer has lots of. It has lots of memory, and it's useful for doing calculations. That's a done deal now. We've completed that. And you now kind of have a mastery of how to work with variables, hopefully. We now are going to move into our next unit, which is not about memory, but it's about control, just like we just saw in that demo. It's about controlling things, taking charge, making the computer do exactly what we want it to do. So some of the fundamentals we need to do in this unit is ask questions, like should this guy get in or not, right? Control things through logic, make decisions, and act as a gate to let things in or out. So this was written a couple units ago, and now you can see how that applies to what's going on. Now, where this falls in the larger picture, I have a little interactive demo for you, whee, okay, is that in Unit 1, we learned the theory that computer science is problem solving. We talked about problem solving in a general sense. Then in Unit 2, we started learning this thing called the IDE, which was an environment to use coding within, and then we did variables, how to work the memory. And now we're jumping to the next step of our programming logic, which is the idea of the conditional statement. The thing about computer science, as I've said before, is it is an incremental learning. If you have not finished the variables unit, you are going to have difficulty jumping to this step. If you have not finished the unit before, you can't do a two-step jump. It doesn't work that way. These are directly one after the other. And the goal will be to eventually get to the final project where you just make whatever you want. But in order to be able to do that, you need these pieces in place. Some units we haven't covered yet that are coming up. But the unit we're currently at is the place where you want to be as you approach this. Okay? So as I said before, variables was about memory. Okay? And that's done now. We've kind of mastered that. And now this unit in conditional, okay? Conditional, let's just take the word for a second. The root of it would be a condition, which is like we had up on the back of the door, some sort of conditional. Statement is just something you do when you speak, right? You make a statement. Now, we're not actually speaking verbally, but we're making statements in our code. So it's basically writing code to create a condition. This is about logic, or more specifically, control. We are controlling the computer in this unit. We're allowing it to get smarter in the way that this works. Okay? So that's what the unit's about. Let's get started. Okay, so every day you make decisions, okay? Every day. Just this morning you might have made these decisions. What am I going to wear? Should I have a big lunch or not? Should I even get up this morning? How big a present should I bring for Mr. Walks, the wonderful computer science teacher who's giving me all this knowledge? All maybe just this morning you made those decisions. Even this morning you might have said, well, you know what, if it's raining out, maybe I'll wear a raincoat and bring an umbrella. Okay? Maybe tonight you'll think, well, if I have a test tomorrow, then I'm going to study tonight. Otherwise, maybe I'll just watch a movie. Decision making is a big part of your life, and now we want to make it a big part of our programming. And what you see here is what we called pseudocode. It's not really code, but it's written in a way that could be, hopefully maybe later, interpreted into code. So decisions are made on conditions, right? If it's raining, that decision was a condition, right? When you evaluate the condition, the answer is true or false, right? It's raining or it's not. If it's true, one thing occurs, and if it's false, some other thing occurs. This is going to control the way the program flows. We've seen this before. We saw it way back when we talked about flowcharts. When we came to a condition in a flowchart, it would either do action 1 or action 2, but it would never do both, right? It's like when you reach the fork in the road, you can go left or right, but you can't go both ways. Your decision affects the way things flow, okay? So this fork in the road is based on instructions or code that you write that will make a comparison and make a decision, okay? At its basic level, this is teaching a computer basically the basics of thinking. So a computer says, which of these is the bigger number? It's not actually thinking, but it's making a decision that this one is the bigger number, and then it acts on that decision, okay? So this ability to write decision-making code is what the conditional statements unit is, okay? It's a control structure that will control the way the program flows. Now, I anticipated what you guys would look like today, so I drew a picture in last night thinking about what it was. Sorry, it was just the male one, Aaron. I didn't get around. But Blaze, this is my interpretation of what you might look like. I actually thought it was pretty good. Didn't get the hair quite right, and I'm not sure if your eyebrows are quite that way. But you are the bouncer, controlling whether or not something comes in or out. If you meet the condition, you get in, okay? It opens the gate to allow you to flow into that part of the program, okay? This is a huge piece. Once this piece is in place, what your programs can do jumps up significantly. Just like Mario leaping up the stairs, now your programs can do a lot more. This is called the if statement, okay? It's why the badge was worn the way it was. So what is this thing, okay? Well, the if statement is basically written as a keyword. The keyword if is written into your code. If you meet a condition, then it runs the code. Okay, now let's look at the structure of how that works. To understand the structure, since we're making a comparison or test, we need to understand these things called relational operators. This is the part that maybe got you guys a little bit confused today when you looked at what was on the back of the door here. Because some of them looked familiar to you, but some of them looked a little different. So these things called relational operators are the things that you'd expect if you were in a math class. This means less than, this means greater than. There's no difference to the math class as to what you see there. But now in computer science, things start to look a little bit different, mostly because we type this and we don't write this. So this means less than or equal to, okay? This means greater than or equal to. I know in math class you write them differently. You write them with the little line right underneath. But that's not easy to type. Okay, it's not a key on your keyboard. So as a result, computer science just made the process easier by placing it in that way. Now, just so you know about these things, you cannot reverse the order on this. It's always going to be the less than or equal to. That's the way we usually say it too. I don't know many math teachers that say equal to or less than. They usually say less than or equal to. So always think of it going that way. Okay? Now, it gets even more weird. This one means equal to. And this one means not equal to. Again, in math class, you would write them very differently, okay? So let me just draw you a comparison, right? In math class, things would go the same. Like I'd say, is 5 less than 10? It's all good. I could say 10 is greater than 5, okay? But I could also say 5 is less than or equal to 5, okay? That's how we'd write it in math class. But we're not writing, we're typing. So in computer science, less than or equal to is put that way. You probably got that one. That one wasn't too bad. But then, this is how you'd write in math, 5 equals 5. Okay? Now, if I bring in variables, like in math class, I could do this. Now, does that mean x equals 5? Or does it mean x is becoming 5? It could mean essentially both, right? It could mean, well, x equals 5, or I'm putting a 5 into x. So computer science got away with that. It said, you know what? No, 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 no. This means put a 5 into x. This means compare the two. Does x equal 5? This will give you an answer, yes or no. So what computer science does is it's a little more specific again, that a double equal sign means to check to see if two things are equal. Okay? And again, not equal in math, you'd write it like this. X is not equal to 5. But again, that's not easy to type. So the symbol we use in computer science is the exclamation point to mean not equal. Okay? It's a bit weird. It's a bit quirky. But you're going to have to get used to it as you learn how to code with these new relational operators in computer science. Okay. So basically the way it's going to go is you're going to write an if. You will now also use round brackets, just like you would in math, to kind of sort of specify what you're testing. Then you put a term, the relational operator, and another term. Those terms can be anything. They could be a variable, they could be a number, they could be all kinds of different things. Again, we'll do this in an example. Okay? But if in general that condition, the test I'm doing right here, the test that's inside the brackets becomes true, then it moves on to code. Okay? So let's do this. Here's what I need you guys to do. I need you to build this for me. Okay, let's fire up your monitors and let's get started with this quick build. We have to work quickly today. Okay, so here's mine, as I've shown you before. I'm going to give it a quick run just to make sure it does actually run. And there it is. Okay. I can check over here to make sure all my objects are named, and they are. Let's see, everything has got its proper name that I've named it. I'm now ready to start coding. So we're going to start by coding the button called Enter Values. So I want you to double click the button called Enter Values. And I'll zoom in. And we're going to type code inside this button. Now, what you're going to see as we start this is nothing that you haven't seen in the last unit. What we're going to do is we're going to pull the information out of the text box and store it, just the same way we did in the last unit. We're going to create a string of text by going to txtinput.text. Okay? This is something we did in the last unit. So a variable is created, and it takes what's in the text box and stores it. Okay? All right. Now, the first thing we're now going to do is we're going to check the contents of this variable. We're going to take a look at what's inside there and make a decision, just like our bouncer did today, by writing an if statement. So here's how the if statement is structured. You type if, notice it appears in blue. It's a keyword. Always lowercase I, lowercase f. Then we have round brackets. Inside the round brackets, we place our condition. And our condition is if the text equals, and we're just going to put two quotes there. The two quotation marks indicate that they put nothing in that text, right? Two quotes beside each other means there's essentially nothing there. So if they typed nothing in the text box, this if statement will check that. It's asking the question to the computer, hey, is there nothing in that text variable? And if there is nothing, we're going to do something about it. So what we're going to do is determined by placing, next thing with the if statement is you place these curly brackets, okay? A beginning and an ending curly bracket, okay? What these do is they set up the structure. This is like our classroom was in the demo. Only if it passes the test does it get into the code that's in between these two brackets. So this is like the club in here. This is the club. And you can only get into the club if you meet the condition. Okay? So those curly brackets create the structure that builds what we go into. So let's put some code in between those two brackets. When you put code in between the two brackets, you're going to notice that C# does something strange with the code. It indents it. You'll notice that it's not lined up anymore. It's like sort of indented. This is a style thing. With if statements, we do this to kind of create a visual cue that we're like in the club, like we're inside of something that is being controlled. So let's just put the line application dot exit. We've seen that line before with the brackets, or sorry, the brackets. What that does is it shuts the program down. So it'll only shut the program down if they put nothing in the text box. Let's see if it works. I play it. I put nothing in the text box and I hit enter values and the program shuts down. Now watch again if I run it a second time, and this time I type a number in there. It should now fail the test because it will not be empty. And notice it doesn't shut down this time. This time it stays running. Only when this thing has got nothing in it does it shut down. Okay? So this is the first application of the if statement. It controls things. It sets up a set of control that controls whether or not the program does this. Okay? Now, let's get a little more interesting with it. Before we exit, let's add a line of code. So we're still in between these two curly brackets. So we're still, quote, in the club, right? We're inside this structure. We put one line of code. Who's to say we can't put another one in there? So let's put another one. Now this is a line you would have seen if you've done the case studies. If you haven't done the case studies, you haven't seen this line. Message box. Okay? Notice it's a keyword. M-A-S-S-A-G-E, capital B-O-X, message box, dot show, opening bracket, quotation marks, you need to type something. Dummy. Oh, I'm not going to type that. Close bracket, semicolon. Okay, so there's a structure to this line of code. Messagebox.show, quote, you need to type something, close quote. Now, let's see how that works. I run it. I leave nothing in the text box, and I click Enter Values. What that line does is it creates one of these. This is a quick way to create what's called a little message box. We didn't have to design that. It just is like automated code that will just automatically pop up, and then it shuts down. So it did this line, and then it did that line. But again, it only did those two lines because the bouncer let them in. If I type something in that text box, there, see I typed something in the text box, it doesn't let me in, right? Only when that thing meets the condition of being empty does it then execute that code. This is the basics of the if statement. It's very simple in its construct, but it requires some getting used to because it's new code now to learn. Okay, new code to get used to as you write it. Okay, so this is in the notes. You can see it there as well. In the notes, I also break it down line by line a little bit for you guys. So hang on while I get this up and running. There we go. So here you can see it in the notes. It's right there, same stuff. Okay. The first line, as you said, is just a review from the last unit, creating a variable and storing the contents. Then the if statement, that's new code, right? That uses a relational operator. It compares if it's equal, okay? It also uses the round brackets and the curly brackets. So you're going to be getting used to using a lot of brackets with coding, okay? It helps you to keep things organized in your code, definitely. Now, it's not like you haven't seen some of these brackets before. You've seen them appear on your screen. You kind of just didn't know why we're there. So basically, brackets are used to structure things. Okay, they're like the foundation of the structure. Okay. The last line, this message box, we're going to go into more detail about that in a second. And then application.exit we've seen before. Okay, so that line was true. We met the condition. So the bouncer said, "Come on in." Okay, because it was true, it executed the code. Okay, the first time we ran it, there was nothing in the text box. Okay? So those two lines executed because it was true. Okay? Now, another way you can think of these curly brackets is in the concept known as a block. Okay? So what a block is the code that's in between curly brackets. Okay? That's a way you can think of it. But code that executes as one giant grouping is said to be in a block of code. Okay? So in this example here, we have two lines that are in a block. So the curly brackets create a block. They create the club that only happens if the if statement's true. So those two lines are said to be in a block. Okay? All right, now, a couple quick things about this thing called message box. It's fun to play with, so just so you know a little bit about it. Message box is what's called a built-in function in C#. There are several of these. It's specific to C#, though. This thing called message box is not something you're necessarily going to run into in other programming languages, okay? But it creates that little dialog box for you that you can use sometimes to just give a quick message to the user, especially if it's something like a mistake, so you can yell at them, so to speak, okay? So that produces that, right? Like, well, it would just be hello, actually, not hello world, but it just creates that little dialog box. You don't have to design that. It just pops it up for you automatically. Okay. Now, we've now got the basics of if. We bring in the helper at this point. We bring in else. Else is used to control the flow when something is false. Okay? So right now, the way the if statement works is it only works if it's true. But what if it's false? Well, if it's false, it does nothing. But now we can have else step in and say, well, if it's false, I'll take over for you. Okay? So here's a really complicated way of explaining it. The code following else only executes if the first if statement is false. If the first if statement is true, then the code after the if statement executes, and the code after the else does not. That might be a bit confusing to you, so let's tie it into our example. Okay? So let's jump back to our example. Okay. So now, I want you to go back to your design and double-click the checkbox where it says see sum. Okay? And we're going to type some code in this thing. So whenever they click the checkbox, here's what we're going to write. If, okay? So now again, we're inside the checkbox. If check csum, that's our checkbox, dot checked equals true, okay, we will do something. Now what that line is basically saying is, it's not using a variable this time. It's basically it's asking the question if the user has checked the checkbox, right? That's what it's saying, right? If that thing called checksum, if it's checked properly is true, then I should do something. What am I going to do? Well, I'm going to say LBL output dot visible equals true. So I will only see that label if they've checked off that we should be able to see it. Okay? So if it's checked off, display that label. And then, here's the new code. After this structure, after the if structure, you can then, and again this is optional, you can write the keyword else. That's where the helper comes in, the word else. And else has its own structure. So you put a second set of curly brackets for else. Now it's important that you kind of get, this is a place where I find students sometimes screw up. They write else and they get the brackets kind of all mixed up. So notice again, this is simple. And all I'm going to do with this is say LBL output dot visible equals false. So it's either true or false depending on if it's checked. So if it's checked, make it visible. If it's not checked, make it invisible. Watch how this works now. It's very simple. Play it. When it's checked off, you can see it. When it's not checked off, you can't see it. So I check it off, I can see the answer. I uncheck it, I can't see the answer. It's very simple. Okay? This, by the way, would have been the answer to the question, how do I do this back in the font changer program that we wrote way back in the day. Okay? It would require you to know what this thing called the if statement was. That's why I didn't worry about it back then. Now you can see how that starts to get structured. What's different about this is the addition of else. Okay? Else is optional. Okay? As you saw before, we can write if without an else. Okay? Else is just there if you want it to work on both true and false. Okay? So it either executes this line or this line, but never both, right? It decides, do I do this one or this one? But it's never going to, it can't possibly do both. It can't make it both visible and invisible at the same time, right? So it has to choose. It has to make a decision. That's what else does, okay? So as it explains in the notes, the else statement is used when we have two conditions to code, both true and false, okay? So basically, it tested this. If it was false, the bouncer doesn't let you in, and instead it drops to else, and then the bouncer's assistant takes over and executes his or her code. Okay? But if it was true, if this became true, then the bouncer would let you in, and the if code would execute, and then the bouncer's assistant wouldn't do their job. It's one or the other, just like we did when we did flowcharts. It's a fork in the road. Okay? Let's wrap the example now. Get a couple more things quickly to do with the example to wrap up today. All right. Let me just clear that off there. Okay, so we're going to go back in our code to, we're going to scroll up to the top of our code. And we're going to create some global variables again. So global variables, you may remember, you create after the words public partial class and after that bracket. So you make some room for yourself in here. Just hit enter a few times. And let's create two global variables. Int sum, which equals 0, and int count, which equals 0. Okay? So these are the two global variables that we're going to create up here. These are global, which means, what does a global variable mean? It means it's available to multiple buttons or multiple objects. And we have a few buttons in this one. But the other thing about global variables is they never forget. They're like the elephants of the program. They never forget what their value is. So they don't reset themselves unless we reset them. Okay? So we have these two global variables. Next thing we're going to do is I want you to go back down in your code to this enter button. Now I'm just going to get rid of a few spaces. You don't have to do that. Okay? And we're going to add some code. Now, be careful. We are adding code after this bracket, so in here, but before this one. So here you can see where the brackets can throw you off. These brackets are essentially like structures. So if you accidentally screw up one of the brackets, the whole thing sort of collapses on itself. So we wrote these lines of code. We're just putting code after that. Okay? Inside the button called enter. Is anyone lost? Okay, or at least you're not telling me if you're lost. Okay, so what we're now going to do is we're going to add an else. Oops. Okay, let me zoom in a little bit. So now we have if, else. So we added the else now, which we didn't have before. So if it's blank, we'll do this. But if it's not blank, we're going to go down here and do this. Okay? If it's not blank, we're going to do code like we've done before. We're going to say int value equals convert dot to int32, okay, of our text. A line of code that a lot of you kind of had trouble with even on the unit test, we've now typed so many times that I hope you're getting a little more used to it. This is the line of code that converts text into an integer in this case. Okay? So we've turned the text into a number. And remember, we've already checked the text to make sure it's not empty. Okay? Then we're going to do a little formula here. The sum equals the sum plus the value. Okay? Now, as you know, the word sum just means when you add things together. You're summing something up. You're adding things onto itself. So what we're doing is we're keep adding this value to a sum. Well, what's sum right now before we run this program? It's 0. So let's say I type a 10 in the text box. So I type a 10 in the text box. What's 10 plus 0? 10. So then it says the sum becomes 10 plus 0. So now it's 10. But then let's say I type a 20 in the text box and click the button again. Now it'll say what's 20 plus what it was. And what it was 10. 20 plus 10 is 30. And then so the sum keeps changing. Essentially this line of code means add onto yourself. You are adding onto yourself. Okay. Now we're going to add one more line. Count equals count. And what's count right now? 0. Plus 1. We don't need to add anything to it except 1. We are counting. 1. So it'll be 0 plus 1, 1. Then 1 plus 1, 2. Then 2 plus 1, 3, etc. And then we just finish this up by saying LBL output dot text equals sum equals plus sum. Okay? So it's then displays the sum. So let's see how this works so far. I run it. I'm going to type a 10 in there. Enter it. Oh, the sum is 10. Then I go up here and I type a 20 in there. Enter it. Oh, now the sum is 30. Then I go up here and I put in a 50. Enter it. Oh, now it's 80. So you can see it's running the sum up. It keeps adding onto itself. The sum keeps increasing. And I don't need to see it if I don't want to. I can see it or not see it. We already coded that. All right. Now, jump back to your design and code the button count values. Okay, so it's a different button that we're counting now. Okay? So now, this is a whole different button. But what I'd like this button to do is tell me how many values I've entered at this point. Are we remembering that somewhere? Do we remember how many values we've entered so far? Yeah. We have a global variable. We have two global variables. Do one of those keep track of how many values we've entered? It's not sum. Sum keeps track of them adding on to themselves. It's count. Right? Count adds one to itself every time the user enters one. So let's display that. Let's display the count. Let's do it with a message box for fun. Message box dot show you have entered count plus values. Okay. So here's the code. Okay. So now I'm saying I want to show this in a message box. I'm using the variable in between two pieces of text. This is text, and this is text. And in the middle is a variable, which holds a number. And I'm using the plus sign to join them all together. Who remembers the fancy word for that? Concatenate. Yeah, we're concatenating it all together so that when it displays it to the user, it displays it in a nice format. Okay? It's getting tricky. It absolutely is getting tricky now, but let's just see how that would run then. And we'll just sort of keep track in our head right now. So I'm going to type in a 10 and enter it. So I just entered one value, a 10. Then I go up here and I put in a 20 and I enter it. So I've entered two values, the 10 and the 20. Notice the sum is 30 because 10 plus 20 is 30. Now I'm going to enter a 50. That's three values. And then I go count the values. And it says you have entered three values. So it kept track of the count. And we're good to go. Okay? Everything I just showed you as well is available in the notes. Okay? In the notes it highlights the specific areas of the code we just entered. It talks about the idea that these are global variables. In here it talks about that we've added an else part to the if statement, so you know it's there. And it shows the message box again. Okay? This example has tons of clues in it for the next 3 assignments you guys are going to be working on as we start this unit. All right? I think I'll go over